Good morning, students. This is Shivash Patel and welcome to Maths Chef YouTube channel, right? So, last class ನಾವು ಏನು ಮಾಡಿದೀವಿ ಎಕ್ಲೂಡ್ಸ್ ಡಿವಿಷನ್ ಲೆಮ್ಮ ಅದ್ರ ಬಗ್ಗೆ ನಾವು ಕ್ವೆಶ್ಚನ್ ಬೇಸಿಕ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಕ್ವೆಶ್ಚನ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಏನಿದೆ ಅಂದ್ರೆ ಫಂಡಮೆಂಟಲ್ ಥಿಯರಮ್ ಆಫ್ ಅರ್ಥಮೆಟಿಕ್ ಅಂದ್ರೆ ಸೆಕೆಂಡ್ ಕಾನ್ಸೆಪ್ಟ್ ದ ಫಂಡಮೆಂಟಲ್. ಇದನ್ನ ಯಾಕೆ ಈ ತರ ಕರೀತಾರೆ ಅಂದ್ರೆ ಅದನ್ನು ಕ್ವೆಶ್ಚನ್ ಮಾಡೋಣ. ಫಂಡಮೆಂಟಲ್ theorem of arithmetic, right? Okay, in real numbers only. Okay, so fundamental theorem of arithmetic. Before going to this one, let's solve some basic questions. Okay, ಕೆಲವೊಂದು ನಂಬರ್ ಯಾವ ತರ ಇರ್ತಾವ ಅಂದ್ರೆ ಹೇಳ್ತಿದ್ದಾರೆ. 10 ಯಾವ ತರ ಬರೋದು ನಾವು can write it in 2 into 5, right? Again I am focus on the 2, 5, 7, 3, not 9. It is 11, 13, 17, 19, 23. Okay, and again 4, 6, 8, 9, 12, 14, 15, 16, 18, 20, 21. Okay, right. These are the different numbers. Okay, so these numbers, okay, ಅವಿಭಾಜ್ಯ ಅಂಕಿಗಳು ಅಥವಾ ಪ್ರೈಮ್ ನಂಬರ್ಸ್. ಎಕ್ಸಾಕ್ಟ್ ಕನ್ನಡ ವರ್ಡ್ಗೆ ಪ್ರೈಮ್ ನಂಬರ್ಸ್ ತಗೊಂಡು ಸ್ಟಡಿ ಮಾಡ್ಕೊಳ್ಳಿ. These are called prime numbers because these numbers does not have any factors except one and itself. ಈ ನಂಬರ್ಗೆ ಫ್ಯಾಕ್ಟರ್ಗಳು ಅಂದ್ರೆ ಗುಣಲಬ್ಧಗಳು. I can say ಎರಡು ಬಿಟ್ರೆ ಎರಡು ಮತ್ತೆ ಒಂದು ಬಿಟ್ರೆ ಬೇರೆ ಯಾವುದು ಇಲ್ಲ. ಆಮೇಲೆ ಮೂರು ಬಿಟ್ರೆ ಮೂರು ಮತ್ತೆ ಒಂದು ಬಿಟ್ರೆ ಬೇರೆ ಯಾವುದು ಗುಣಾಕಾರ ಮಾಡಕ್ಕಾಗಲ್ಲ, ಡಿವೈಡ್ ಕೂಡ ಮಾಡಕ್ಕಾಗಲ್ಲ. ಸಿಮಿಲರ್ಲಿ ಫಾರ್ 4 ಹೆಂಗಿದೆ ಅಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಡಿವೈಡ್ ಬೈ 2, 1 and 4. 6 you can divide by 2 and 3. 4 it can divide by 2 and 4, 1 and 8. But ಮೇಲ್ಗಲ್ಲ ಪ್ರೈಮ್ ನಂಬರ್ಸ್ ಗೆ you can divide by only 1 and itself. That is the beauty. That is called prime numbers. Okay, right. That is the concept. These are called the prime numbers. Prime numbers and it's called non-prime numbers. Prime. So 10 I can write in the form of 5, 2 into 5. Next 15 you can write 3 into 5. Take any number. These are called composite numbers. These are called composite. Composite is multiple of 2 or 3. That's the hierarchy. Then take 4, you can write 2 into 2. 6, you can write 2 into 3. 8, you can write which one? 2 into, okay, 4 into 2, 2 into 4. This you can write 2 into 2 into 2. Right side okay. E number, see, this can be any composite number, can be written in the form of prime numbers, multiples of prime numbers. So ಇದೇ ನಮ್ಗೆ ಏನ್ ಕರ್ತಾವು ಫಂಡಮೆಂಟಲ್ ಥಿಯರಮ್ ಆಫ್ ಅರ್ಥಮೆಟಿಕ್ ಅಂತ ಸ್ಟಡಿ ಮಾಡೋದು. ಇದನ್ನೇ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇರೋದು. ಯಾವುದೇ ಒಂದು ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ ನ ಪ್ರೈಮ್ ನಂಬರ್ಸ್ ಇಂದ ಗುಣಾಕಾರ ಮಾಡ್ತಿದ್ದ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದಿ 2 ಆರ್ ಎನಿ ಪ್ರೈಮ್ ನಂಬರ್ಸ್, ದಟ್ಸ್ ಕಾಲ್ಡ್ ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ ಡೆಫಿನಿಷನ್. ಓಕೆ, ಅದಕ್ಕೋಸ್ಕರ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದೀವಿ. ಇವಾಗ ಜನರಲ್ ಆಗಿ ಏನಂದ್ರೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡಿದ್ರು ಅವರು 32760. ಓಕೆ, 32760 ಇದನ್ನ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂತ ಬರೋಣ. ಓಕೆ, ಆ ತರ ಮಾಡ್ಕೊಂತ ಬರೋಣ. ಓಕೆ, ರೈಟ್. ಸೊ ದಿಸ್ ಕ್ಯಾನ್ ರೈಟ್ ಆಸ್ 2 into, okay, 2 ones are divided by 2, 2 ones are 3, 6. Okay, compared to 0, 7, and this becomes 7 minus 3, again 8, not 0, 1, 6, okay, 3, 6, 8, 0, right? 16, 3, 8, 0, 2. Again, this I am writing as divided by 2 again. 2 is the smallest prime number. I can divide by any even number. ಅದಕ್ಕೋಸ್ಕರ 2 ತಗೊಂತಾ ಇದೀವಿ. Okay, 2 into again 8, 1, 9 0, right? 8290. Again this divide by 2 into, right? 8290, right? Again 2 4, then 9 1 5, right? Here will come the 40 4095 4095. 4 0 is remaining and 8 9s are 1 with 5, right? Again 2. This is the team 2. Okay, be careful. They not mentioned here, but I have to mention to get clarity. Again 2 0 3. What about this one? 495 or not? Yes. Okay. 2 is not possible. Then I have to do it by the another number. 3 number they given. Okay. I don't know. Sorry. So 3. 3 ones are 10. Okay. 10 is 3 threes are. Again 1 3 18. 3 6 are 18. 1 3 5 are. Okay. This again is possible. 3 3 12 26 24 2 5 ಹೋಗಲ್ಲ 3 ಇಂದ ಹೋಗಲ್ಲ ಏನು ಕೊಡ್ತಾರೆ 5 ಇಂದ ರೈಟ್ 1365 ಅಂತ ರೈಟ್ 1365 ಮೇಲೆ 3 ಇಂದ ಬರುತ್ತಲ್ಲ 3 4s 5 5 ಇಂದ ಹೋಗುತ್ತಲ್ಲ 3 4s 1 ಉಳಿತು ಓಕೆ 16 3 5s again 3 5s again then 4 5 so you can write 555 5 9s 5 1s okay. So next is okay 7 1s 2 7 3s right. Up to we are divided it fully to get the last prime number both sides. Okay, why should do up to here means 13 also prime number. We should divide this to find the product of that number. Either see if it is odd, it may be divided by the 3. If it is even, definitely divided by the 2. Right? Odd means we will divide by the 3, 5, 7, whatever is odd numbers. Okay. Look at here. Okay. Look at here. This one. This is the product. This is the product of these number. Okay. 32760 is the product of 2, 2, 2, 3, 3, 5, 7. Okay. This we can write. This we can write 32760 is equal to 2 into 2 into 2 3 2 into 3 into 3 into 5 into 7 right. ಈ ತರ ನಾವು ಬರೀಬಹುದು. ಈ ತರ ಬರೆಕೆ ಹೇಗುತ್ತೆ ಇದಕ್ಕೆ ನಾವು ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್. ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಏನ್ ಕರೀತಾರೆ? ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್. ಯಾವುದೇ ನಂಬರ್ ಕನ್ನ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ composite number or composite number of prime factorization. Okay, ಆ ತರ ಕರೆಯೋದು ಅಥವಾ composite number ಅಂತ ಕೂಡ you can call it, right? This is the fundamental theorem of arithmetic. What fundamental theorem of arithmetic tells? Any composite number can be written in the form of prime factorization. And also, if we consider the order, that should be unique. Okay, order is, if we consider the order, means here you can 3, you can write 3, 3, you can write 3 options. Now you can write 3, 2, 5, 7. Therefore, you can interchange the foundation, you can do it. But if you write in the order, or ascending order or descending order, if you consider the order, then that is the prime factorization is unique. Okay, now once you order consider ಮಾಡಿದ್ರೆ that is unique ಆಗಿರುತ್ತೆ. ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಯಾವ ತರ start ascending order or descending order. Okay, therefore this final answer ಯಾವ್ದು ಇರುತ್ತೆ ಅಂದ್ರೆ 3 2 760 is equal to 2 to the power cube into 3 to the power square into 5 into 7. Right? Okay. This now you can write it as P1, P2, P3, P4. Okay. It is not dot, it is the multiplication. Okay. Here you can write P1 is less than or equal to P2 is less than or equal to P3. Like that. If we consider the order, ascending order or descending order, then the prime factorization becomes unique. Right? 13 is there also, no? Mentioned mistake. Sorry. This also 13 is also there. 13. Okay. So this is called prime factorization theorem. Okay. And it is very helpful to find the HCF and LCM of the two numbers. If we done now the number na prime factorization any two composite number na prime factorization bardre we get the LCM and HCF at easiest way. Okay, and this is only for very good example, good subtopic for your competitive exams, especially entrance exam of MBA, UPSC, CSAT, and any CDS and any mental ability question based on the quantum aptitude, right? HCF. Okay, this is important. So any composite number again will be, so this A is a composite number. This can be written in the form of P1 into P2 into P3, right? Order means don't worry about the order. If you consider write in the prime in the ascending order, then it become unit. If it's not ascending order, you can write in the interchange just first 7, first 13, first 5, first 3, like that. Okay. But if you want to consider, it is the manner writing. Writing the increasing order. First we write 2, then multiples 3, then 5, then increasing order. Okay. Then let's see. Let's define the theorem. Okay. This is the called any composite number is can be written in the form of prime factorization form. Multiples of any two or more prime numbers. Any composite number is a multiples of factors of prime numbers. Idana example theorem yathara book okay. Let's see. Yeah, but the definition is, see, almost try to write a definition. The theorem as it is in the book. Okay, if you want to get the good marks, so means either can make my by head or you can make the writing practice. Okay, if you write as it is now, you get the better marks. Okay, in a simple English it's maybe we can understand, but still, just kidding. So every theorem, every composite number, what theorem says here. Okay, every composite number, every composite means product of any two or product of two or more than numbers, multiples. Composite number can be expressed or factorized, right, as a product of primes, as a product of primes, and this factorization is is unique apart from the order in which the prime factor occur. Apart means except from the order order in which the prime factors occurs. The prime factors occurs. Right? Occur. Not occurs. Occur. Right? Once again. Okay. Every composite number, na? Oh, I missed the word. Composite number. Sorry. Okay. Every composite number, this add this number. Okay. Number can be expressed or factorized. Very important, na? Expressed or factorized as a product of primes, and this factorization is unique apart from the order in which prime factorization. Apart means except. If you accept the order, that becomes unique. Okay. If you consider the order in addition to, here it meaning in addition to as well as, here it means in addition to, mean if you consider the order, the prime factorization becomes unique. So here finally we can write A is equal to P1, P2, P3, P4 up to some numbers Pn. You can write Pn. Okay, where P1 is less than or equal to P2 is less than or equal to P3. Okay, infinite up to n. P1 may be less than or equal. Means for 8 you can write 2 into 2 into 2. Here P1, P2, P3 are equal. For similarly for 10, okay, for 10 you can write 2 into 5. So P1 is less than P2. Here is P1 is equal to P2 equal to P3. So nothing but P1 only, na? But still you have the three factors, right? Similarly, there is like that. Okay. Next, again some concept. Some concept is okay. The prime factorization of a natural number. Okay, the prime factorization of a natural number is unique except for the order of its factor. Okay, order now consider model of it. You can write in addition to order consider model. You will get only one unique way. You can write in many ways. Only unique way you can write. Right. Next question is let's check then solve the. Okay. Now the question is there. So it is tricky and logic. It seems to be easy, but I will give you some application question based on this application. Okay. Find the. Okay. Consider example 5 is consider the numbers 4 to the power n. Consider the numbers. Example 5, right? Numbers 4 to the power n, where n is a natural number. Check whether there is any value of n for which 4 to the power n ends with the digit 0. Okay. Any value of n for which 4 to the power n ends with the digit 0. Okay. Now you can take the n as any natural number, right? Natural number. Okay. Here n belongs to small capital N. Okay. Now we have one power can be power so for you can at least get 0. Okay. So the question is digit 0 ends with digit 0 like that. Ends with digit 0. Okay, like that, na? So here 1 4 5 0 is the inner digit, one single. Similarly 1 4 6 0 is ಈ ತರ ಬ್ರೇಕ್ ಆಗುತ್ತಾ 0 ಡಿಜಿಟ್ ಅಲ್ಲಿ inner digit ಅಲ್ಲಿ ಬ್ರೇಕ್ ಆಗುತ್ತಾ ಅಂತ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಇದೆ. ಓಕೆ, ಸರಿ, ಇದು ಕ್ವೆಶ್ಚನ್ ಯಾಕೆ ಯಾವ ತರ ನಾವು ಸ್ಟಡಿ ಮಾಡಬೇಕಂದ್ರೆ, ಓಕೆ, ಸೇ ಎನಿ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಇದೆ ಬಿಕಾಸ್ ನೋಡಿ ಜಸ್ಟ್ ಸಮ್ ಕ್ವೆಶ್ಚನ್ UPSC CSAT ಅಲ್ಲಿ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಇದೆ ಸಿಂಪಲ್. ಕನ್ಸಿಡರ್ ಪ್ರಾಡಕ್ಟ್ 89 90 up to 100, I think so, right? 100. find the number of zeros in this product. Okay, the question is consider the product 89, 90 up to 100. General I am taking, but question is difficult, but same method is same. Consider the product 89, 90 up to 100. Find the number of zeros in this product. Okay, sir. Number of zeros, not the product. Okay, zeros, not the total product. Find number of zeros. Okay, this we can write together. How the link is any number. Okay, sir. Just take if 10 is a unit digit 0, so this we can write 2 into 5, right? Again 20, this is okay 4 into 5, this we can write 2 square into 5, 30, right? 30 we can write 6 into 5, this is 2 into 3 into 5, again 2 into 5 into 3. See here, for any multiplication, any unit 0, 100 you can write 100, you can write 10 into 10, this you can write 2 square into 5 square, because 10 is 2 into 5, 2 into 5, you can write 4 into 25, yes. For getting unit digit 0, the product should be multiples of 2 and 5, right sir? Multiples of 2 and 5, for every multiples of 5 and 2, every multiples of 5 and 2 will get 0 unit digit, 1 0. 2 square into 5 square will get 3 0. 2 cube into 5 cube is equal to you will get 3 0. For every one product you will get 1 0. For 2 product you will get 2 0. For 3 product you will get 3 0. Every multiples of 5 and 2 will get the 1 0. It means this product has multiples of how many times of multiples of 2 and 5. It depends on this number. So here this we can write 90 has 1 5. 1 5 you can write by whatever it may be. Okay, one multiple of something. How 91s are 91s are, that is very important here. 91s are 4, 98s are, right? 8 into 5 is right. Then this we can write 5 into 18. Next number is, so here 5 is common and considering only 5, okay, and 95 is equal to, so 5 into 90, then 100 is only, we have 100 is equal 5 into 25, so 5 into 5 into 5, 120, not 25, 20. So here you can write 4. So what the common is, so you can write 5 into something 92, some 5 into 82 will get a 0, 5 into 92 will get 0. So what I am doing, and okay sir, here not 89, we have the 92, 94, right? And also you can write this one 98. We have the even numbers and odd numbers and multiples of 5 and multiples of 10. Okay, that's what I'm taking 5 as only one number. Okay, because we have the many even numbers, 2 multiples of 2. Okay, but multiples of 5 are unique. Only 10s are 5s. Okay, that I think 1 5 is there, 2 5 is there, right? 1 2 4 5s. If you do the calculator, this has 4 zeros in unit place. 0 0 0 0. Definitely. Okay, 100 you can write, 95 you can write 5, 90 you can write 5, and 100 you can write 5 into 5 into 4. Okay, so here you will get 20. Again you will get here one number 5 is there, and multiple of 82, multiple of 92, 94, 98, 96, and here 5 and 18. I got one 0 is there, right sir? Number of 5s units, okay, number of 5 multiples or number of 5 digits is the itself is there, that's the number of zeros here. So how the question linked to this one is, so if you write this number as a multiple of 5 into 2, okay, that's 4 to the power n, you can write 2 to the power 2 square to the n, g means 2 to the power n. So therefore, this multiple does not have any 5 multiples. Okay, this number does not have any 5 multiple. Therefore, this product does not ends with any 0 value. Do whatever it may be. Not impossible. Okay, that's the answer. Okay. If you write in the form of then 10, you can write 2 into 5. Then you can write in the form, and 20. Okay, just now again only 5 into 2 multiples have zeros. Okay, that by practice you can get the things. Next question is, okay sir, LCM and HCF of 6. Okay, LCM and HCF of, we'll find that one and you can go to the question section directly. This is the very important. This is also very important for the next irrational numbers. Okay, whether the number is terminating or not terminating, decimals. So that's also 5 into 2 is very tricky in real number. Almost any questions based on this number, they will focus on the 2 and 5, multiple 2 and 5. Okay. Next question is, okay, let's find the HCF and LCM. Okay, 6 and 20. Okay, in the old method I will find LCM. LCM is equal to 6 and 20 multiplied by 2. Take the 2 as common, 3, and this is the 10. Right? So these are the, now there is not any common factor, so multiples. 2 into 3 into 10 is 60. Right? What of HCF? Highest common factor is the least common multiple, and HCF is, okay, by what you know, 620 by 6. Okay, how you are writing that exam last it clears division lemma. Okay, 20 we can write 6 into 3 plus 2. 6 into 3 plus 2. Okay, again remainder has 2, so I have to take this one. 6 you can write 2 into 3, right? So we got 0. Those 2 is the LCM. Okay, here we got 0 here. No, 2 is the HCF of 6 and 20 is equal to 2. This is the regular method. So here we will find the LCM and HCF by this factorization, prime factorization. Okay, prime factorization. I will tell the definition also. So 6 we can write 2 into 3 prime factorization, and 20 we can write as, okay, 2 into 5, 4 into 5. Okay. So what are the, so what is the HCF is? Highest common factor. Okay. So HCF definition is, okay, so what is the HCF is? HCF, the books, okay sir. Highest common factor, okay. Product of the smallest power of each common prime factor in the number. Product of the smallest power of each common prime factor in the number. We will write it to get the things done. Product of, okay, product of smallest power. This is important. Smallest power. This is important. Smallest power of each common prime factor. Common prime. This is important. Common prime factor in the numbers. Factor in the numbers. Okay. According to this one, what is the LCM? LCF, product of smallest power of every each common factor. Okay, this is each, PACH. Product of smallest power of each common prime factor. smallest, that product should be smallest, and prime factor number be common, must be common. Okay, for to take the common, what is the common here? 2 and 2. What is the smallest power is 1. Okay, therefore HCF of 6 and 20 is equal to 2. We got it here na? By Euclid's division lemma. And LCM is equal to, okay, LCM is equal to, what the statement is, okay, product of the greatest power of each prime factors. Okay, product of, okay sir, product of greatest power, this is important, greatest power, okay, greatest power of each prime factor, prime number, each prime factor involved in the numbers, right? Very important. See here, we taken the first have taken the common and smallest power. First you find out the common, then check the which one? Smallest power. That is the highest common factor. What else it means? Product of greatest power of each prime number. Right? Product of the greatest power of each prime factor. Product of the greatest power of each prime factor. Product of greatest power of each prime factor. Okay? Each prime factor. Here common prime factor. Here is each prime factor. Okay, greatest, that's 2 greatest. Okay, so this you can write 2 to the power 4 into 5 to the power 1. Okay, so what are the common, okay, greatest powers? Each greatest power of each prime factors. Okay, sir, I am taking it very carefully. LCM of 6 and 20. Okay. Product of greatest power of each prime factor. There are 3 prime factors, 2, 3, 5. So I will write 2 into 3 into 5. First, then I have to choose the greatest power. What the greatest power is? 2 has 2, not 4. This has 2. 2 has 2. 3 has only 1. 5 has only 1. If you have 2 3's, you have to write 3 square. If there are 4 5's, you have to write 5 to 4. 5 to the power 4. So this becomes, what is 4 into 3? 12. 12 into 5 is 60. We got it here na? 60. By our common method. Okay. Right. Okay. This is important. For LCM, you should take the common factor first, then smallest power on the common factor. Product of smallest power of the common prime factor. Okay. Common smallest power. Product of smallest power. Okay. Right. So here you can write also. If you want this one, this you can write 5 to the power 0, this to the power 1, and this also 5 to the power 0, 3 to the power 0. Okay. To understand only this, we can become 3 to the power 0. Okay, we can write now because 3 to the power 0, a to the power 0 is 1. So in terms of product, you should take, what are the common here? 2 into 3 into 5. 5 commons. So smallest power of 2 is 1. That product. Smallest power of 2 is 0 and 0. And this becomes 2 into 1 into 1. This becomes 2. Okay. In next example, you get to know how the HCF and the LCM different ways. Here, smallest power, it is the greatest power. LCM has the greatest power, HCF has smallest power. Again, there is one peculiar idea is there. One peculiar means, okay, let's multiply the HCF and LCM of 6 and 2. Okay, just multiply the HCF of 6 and 20 into LCM of 6 and 20. What is F is 2. What is LCM is 20. This is 120, right? Similarly, not 120. Yes. Okay. Again, multiply. Just take the 6 into 20. You have got 120. Right? These are the number. These are the LCM. Very important here. The numbers, multiples of the numbers. The product of the numbers is also 120. The product of the LCM and HCF also 120. Right? So, this you can write, okay, this 20, you can write 120 is equal to 2 into 60, you can write 6 into 20 is equal to 2 into 60. 6 into 20 is equal to 2 into 20. So what is 2 and 6 here? Okay. Very important here. Okay. A into B. So A into B is equal to L into H. This is the formula. A and B are numbers and L and H are LCM and HCF respectively. Okay. A and B numbers where we have to find the corresponding LCM, and L is LCM and H is HCF. Very important. This is the formula. Okay. Based on this, we have the some questions. Okay. Also exercise also. Okay. Product of ಈ ಸಾವು ಯಾವ ಸಿ ನಾವು ಇಲ್ಲಿ ನೋಡೋದಪ್ಪ ಅಂದ್ರೆ ಲಸ ಮತ್ತು ಮಸಗಳ ಗುಣಲಬ್ಧ ಮತ್ತು ಎರಡು ಸಂಖ್ಯೆಗಳ ಕೊಟ್ಟ ಸಂಖ್ಯೆಗಳ ಗುಣಲಬ್ಧ ಕೂಡ ಸಮಾನವಾಗಿರುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು A into B is equal to L into H. Product of numbers is equal to product of corresponding LCM and HCF. Okay, we solve some questions. Okay, let's see, sir. Our question is, so exercise part is completely easy, so I am going to skip for this one. Okay, anyway, I am going to solve the RD Sharma for one class. I will pick some question from the RD Sharma. After we complete the whole chapter, real numbers, I will pick some important questions from the RD Sharma for one class. I will prefer only for the solutions method. Question and solution from the RD Sharma. Exercise, these are easy, almost I think so. Okay. ಇಲ್ಲಿ ಸಮಸ್ಯೆ ಇಲ್ಲ. ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ನೋಡೋಣ. HCF 3 numbers ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದನ್ನ ಯಾವ ತರ ಮಾಡೋದು ಅಂತಂದು HCF, find the HCF and LCM of 6, 72, 120. LCM and HCF of 6, 72 and 120. Right? 2 into 3 can write. This we can write 2 into as 2 into 37. Right? 35, 36, 36, 35. Again, this is 2 into 16, 2 into 18, 18 into 2, 36. Right? This we can write 2 into 3 into 6. So this gives, can write is 2 to the power 3 and 3 to the power 6. Right? 8 into 9. Yes. So this is the 2 to the power 3 and this is the 2 to the power cube and 3 to the power 2. And this is 120 is there. 120. You can write 2 into 60. Right? This you can write 2 into 30. This you can write 2 into 15. This you can write 2 into 3 into 5. This you can write 2 to the power cube into 3 into 5. Okay. What the LCM? LCM of 6, 72 is 120. Greatest power of the each prime number. Greatest power of each prime factor. Each, everyone. Okay. What are the prime factors in order? 2, 3, 5. 2 into 3 into 5. So greatest power is here 3 is there, here 3 is there, here 2 is there. So greatest power is 3 among all. And here 3 is there, here 2 is there, and here 1. Again has the 2 is greatest power, and 5. This is 5. This does not have 5, no? Yes, only 1 5 is there, right? So 5. This is the LCM. This is 8 into 9 into 5. This becomes 72. 72 into 5. Okay, or 72 into 5. 720 by 2. 360. I think so. LCM is 360. Yes, sir. LCM is 360. What about HCF? HCF of 6, 7 to 120. This is equal to. What are the prime factors involved here? 2, 3, and 5. Smallest power of common prime. Okay. Smallest power of common prime factorization. Here is each prime factorization. Here common prime factorization. Okay. Common smallest power is we have 2 cube. 2 cube smallest is to the power 1, and 3 square, and 3 and only smallest is 1. Again we have 5 1 here is there. Only we have do not have any common factors of 5. This is common, very important. Common, there is no common 5. 5 we have only for 120. We do not have 5 and for 120 and 6. So 5 is 0. Because no, this you can write 5 to the power 0. This you can also 5 to the power 0. Smallest power is 0. This is 2 into 3 into 1. This is 6. Yes, HCF is 6. Okay, sir. Smallest power, very important. Power on common prime factor. Common prime. Here, greatest power on each prime. Greatest power on each prime. We are not common. Each prime. Right? So here 6 only divides 6, 72, 120. But here only 360 gives, 360 is a multiple of 6, multiple of 72, and multiple of 120. 120 into 3, 360, 72 into 5, 360, and 6 into 60, also 360. LCM is the minimum common multiple of, the first multiple of these 3 numbers. We get the first multiples of, common multiples of first common multiple. In 120 also have the nearest small, and in 60 also small, and 60 also have the common multiple for both. Least. Okay. Then again 360 is there, 720, double, triple, multiple of 360 are the common factor, common multiples, but 360 is the least, the first one. So here common factor is, so 6 you can divide 6, 72 and 120. This is like multiples, this is like divider. HCF is the common factor, common number divides all 3 numbers, all given numbers. Should remember. And this is the product unit loss number, which gives the, is just some number. If you get the multiple by something else, you get some number in future. What is common is, should get the all 3 numbers in some areas. If you multiply 120, you will get 360. Multiply by something by 102, we will get again one number, and 60 will get the again number. That is the least count multiple. This is factor, divider. Okay. Origin. So questions are, again, the question is, I'll just explain here. I explain why 7 into 10, 7 into 11, 13, and plus 3, and 7 into 6 plus into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. See, what are the composite number? Multiples of factor of prime factorization of the any prime numbers. Okay. So if you add and subtract, you can get the composite number. You can get the, cannot get the this one main number. Based on this, you can solve it. Okay. How they composite number means product of only two numbers is the composite number already. So addition and subtraction does not alter the composite factor. Okay. Composite number. Okay. See also. See the answer also. Here we do not have any much deep questions. Check whether the 6 to the power n can end with the digit 0 for any natural number. 6 to the power n, they ask the question. So here 6 to the power n, we can write 2 into 3 to the power n. This is 2 to the power n and 3 to the power n. Again, we do not have any multiples of 5. Any multiple of prime number 5. Therefore, this number does not end with any 0 number at unit place. Does not end with 0 at unit place. Right? Does not, cannot end with the, okay. Only sir, 10 number and then these numbers are only end with the 0, multiples of 10. Okay. So I am going to conclude this one. Okay. Questions are very easy, that easy, and while solving the addition, you can do it. And next concept is irrational number. Irrational may have two options. Okay. Okay. Irrational numbers have two concepts. One is whether prove the given number is irrational or not. Second one is decimal expansion. Whether the number is terminating or non-terminating. Okay. And I think so if possible, both concepts will do in the single class. I will take the separate classes. Okay. Thanks for watching. And this for the again I'm telling you, Kannada medium so little bit. So completely I am familiar with the English language for these months. So in between I will get the English as a by heart, by performance. But okay, adru kuda try martini. Comment box alli ನೀವು ಯಾವ ತರ ಕಮೆಂಟ್ ಮಾಡ್ತಾರಲ್ಲ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಯಾವ ವರ್ಡ್ಗೆ ಇಂಗ್ಲಿಷ್ ಮೀನಿಂಗ್ ಕನ್ನಡ ಮೀನಿಂಗ್ ಬೇಕಾಗುತ್ತೆ, ಯಾರಿಗೂ ಬೇಕಾಗುತ್ತೆ ಅದ್ರ ಮೇಲೆ ನಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಯಾವ ಜನ ಜಾಸ್ತಿ ವಾಚ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಇದನ್ನ ವಿಡಿಯೋನ, ಕನ್ನಡ ಮೀಡಿಯಂ ಜಾಸ್ತಿ ಕನ್ನಡ ಯೂಸ್ ಮಾಡಲೇಬೇಕಾಗುತ್ತೆ, ಇಂಗ್ಲಿಷ್ ಮಾಡೋಕೆ ಇಂಗ್ಲಿಷ್ ಮೀಡಿಯಂ ಜಾಸ್ತಿ ಮಾಡಲೇಬೇಕಾಗುತ್ತೆ. ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದಿ ಡಿಮ್ಯಾಂಡ್. ಓಕೆ, ಡಿಮ್ಯಾಂಡ್ ಅಂದ್ರೆ ಇಂಗ್ಲಿಷ್ ಜಾಸ್ತಿ ವಾಚ್ ಮಾಡೋಕೆ ಆಟೋಮೆಟಿಕ್ಲಿ ಹ್ಯಾವ್ ಟು ಸೊ ಫಾಲೋ ಇನ್ ದಿ because the majority rules, majority prevails. The 90% are watching English and 10% Kannada, so cannot help. So only can help some their difficulty level, some questions or some answers or something else, but have to follow the trend demand. So thanks for watching and give your valuable feedback. Thank you very much.